what happens when you have a C filter with R load at the output of a three-phase diode bridge rectifier? We know that two diodes can conduct at any given point of time, one from the top group and one from the bottom group. And the two diodes that can conduct at any given point of time are also listed here. They go in a cyclic manner, D5, D6, D6, D1, D1, D2 and so on. But then when we have a capacitor, the diode conduction cannot happen unless the input voltage becomes more than the voltage across the capacitor. Let us try to understand this with an example. Let us start with omega t equal to 0. Time t equal to 0, we start the circuit. And we need to know something else also. What is the initial voltage on the capacitor? Let us say the initial voltage on the capacitor is 0. That is also given to us. When the initial voltage on the capacitor is 0, if we just start this circuit, you imagine a switch being here and it is just being closed. What will happen? D5, D6 can start conducting. Why? If we assume that D5, D6 are off, the voltage across them will be positive, so they will definitely be on. Now what is the circuit that we are looking at? We have a circuit like this. We have this voltage source, then you have these diodes which can be represented by short circuit. You have a capacitor and you have another diode to close the current path, and of course you have a resistor. There is nothing to limit the flow of current in this loop. So what happens? Huge amount of current is drawn. Huge amount of current is drawn and the capacitor charges to certain voltage. And what is that voltage? It will charge to root 3 Vm, the maximum voltage. Once the capacitor charges, and when does the flow of current stop in this circuit? We already know the flow of current stops in the circuit when the diode current tends to become negative. Let us say that happens at this moment, this particular moment. So by this time the capacitor would have charged, so the output voltage is VO, and from here what happens? Since the diode stopped conducting, no other diode can conduct. Only D5, D6 can conduct up to 30 degrees. So for the remaining time, what is the equivalent circuit now? The equivalent circuit is just an RC, because no diode can conduct in this interval. So what happens to the voltage? The voltage falls exponentially. Let me represent this with a zoomed figure so that you can understand better. So we started here. In fact, the voltage was 0. The voltage would immediately rise because a huge amount of current, a huge charge is directly pumped into the capacitor, and the voltage becomes equal to root 3 Vm, and soon after that huge current pulse, quickly the diodes stop conducting at this point, and from here the voltage will fall exponentially. And when will the exponential fall stop? The exponential fall stops when it becomes equal, the voltage of capacitor becomes equal to the voltage VRY. And now D6 can continue to conduct and D1 can come in, because D6, D1 are the possible candidates for conduction in this interval. So, but they won't start conducting immediately at 30 degrees as in the case of R load. Now they will start conducting at an angle pi by 6 plus delta. Pi by 6 plus delta. And as D1, D6 conduct, the circuit will again be same, but now this VBY is changed to VRY. So once again the capacitor voltage follows the input voltage, and the diodes stop conducting at an angle pi by 3 plus gamma. Pi by 3 plus gamma, because at pi by 3 the peak of voltage, line to line voltage occurs. and the diode stop conducting at pi by 3 plus gamma. Once the diode stop conducting, the voltage fall again will be exponential. Let us look at the current. Initially the current was huge because it is 0 voltage on one side and root 3 Vm on one side. That is why the current was huge, and then the current was 0. Then it remained 0 till pi by 6 plus delta. Then now the current will be relatively smaller. The peak of current will be relatively smaller. Why? Because the capacitor is charged now and its voltage is almost close to root 3 Vm. It is definitely more than 1.5 Vm. Peak of current can be calculated in the same way that was followed for single phase rectifiers. We will see expressions soon. Once the diode starts conducting, that is from pi by 6 plus delta, the current follows a sinusoidal shape. We know how to determine this shape. It is Vm by R sin omega t plus this capacitor current omega c Vm cos omega t. It follows that kind of shape. And the diodes stop conducting at pi by 3 plus gamma. And in this interval, no other diode can conduct. So the voltage falls exponentially, as we have explained. And here again, D1 can continue to conduct. So the current through D1 will have a similar shape. And now the current through D1 becomes 0. And D1 cannot conduct anymore in any of the intervals. Similar things can be observed in the other phases. For example, if you look at the current through D2, it would be having some kind of pulse here and another pulse here. And if you look at the current in D5, the current through D5 would be having pulses in these two intervals. And D4 would be having pulses in these two intervals. Like for example, D4 we can conduct here and it can also conduct here. So that will be reflected as negative current in on the source side. So it will have this kind of shape. So the source current will again have 0 average value, but then this kind of 2 peaks in the positive half and 2 peaks in the negative half will be present. That is how current conduction happens in a 3-phase diode bridge rectifier with C filter and R load, and our output voltage will be having sections of sinusoids and exponential falls. And this sinusoid plus exponential fall will last for 60 degrees effectively, and it keeps on repeating. That is why there are 6 pulses in the waveform in one period of output voltage waveform. But what is the problem with this circuit? The problem with this circuit is the fact that there is no voltage initially on the capacitor. If there is no voltage on the capacitor, we are going to end up drawing huge currents from source and the diodes are likely to be damaged. That is why in real world applications, these capacitors are charged by a separate circuit known as pre-charging circuit. They will charge this capacitor to something like close to root 3 Vm, and then they will turn on the diode bridge rectifier so that the current peaks are not that much. That is achieved through relays and contactors.